Hello and welcome to chapter 4, first half, where it's the easiest part, and the second half will be taught by my other friend. So let's get on to the first part. Alright, so this is the very first thing that we should be learning, is when we have an equation like this, is the first thing we would do to find the interval of increase and decrease is actually y prime, which is right here. And if you don't understand how to do this, is you just want to when y equals let's say xa, right? Then when you y prime it, then it's gonna be prime equals to a x, where you move this down here, to a minus 1. So as we did over here, as you can see, x3, 3x2 as 3 come down, then minus 1, then 6x minus 2. As this, if a is 1 already, for example x, if you see x is like this already, it's actually x1. And when 1 minus 1, it becomes x power 0. And x power 0 is nothing. Therefore, the number 2 is gone. It's already gone anyway, so it will just be another gone. So after we have got the equation, then we're going to be looking through letting y prime equal 0, so we can find the x, and this will let you do the whatever. You can use the calculator or butterfly method, as I really use a calculator so it's quicker. So this is a shortcut, and when you do this, you will get x equals -2 and x equals 0, which are the critical points. We're going to get through on how to use this later. So after you've done step 1 to find the x's, we're going to go to step 2, which is making this table over here, where x is the top, y prime is below, and y is here. Right? You get the point. So we're going to write down from left to right. So first, when you put the 2 points, what we got from here, you're going to sub it into the middle somewhat. And whatever behind it is because we want to know if it's going up or down, the local min or max. We got to figure that out with the y prime that we're going to be figuring it later. So I'll tell you from here. Okay, so from -infinity to -2, we will sub in a -3 from here, because when we are at, let's go over here. So when you have a table, a graph like this, and we're at -2, we want the value from the smaller part and the bigger part. You can do 2.5 as well, but we like to use the whole numbers as it's easier. So you can do number 3, and you can see that when you sub in, -3. So when you sub in a -3, which is smaller than number 2, we can see that it is bigger than 0. And where do you sub this? It's in the y prime that we've got, not in the y normal, the y prime. So you sub in a -3 into the y prime equation, and it will give you a value that's bigger than 0. And when it comes to bigger than 0, then the interval increases. It's going upwards because it's positive. And when it reaches to -2, that's the local max, as we know, because from what we saw from here, this gives the idea that it's a local max. But you also has to check from the right side too, because it could also be a saddle, or it could also be like, an imposter, So we're going to go to -1 and check on out. And we have done that already to make this thing faster. And -1 will give you smaller than 0. And when it's smaller than 0, then it's going downwards. So because it's going downwards, now we know that it's actually going like this. Up, local max, then down. Yeah. So now we're going to go from 0. 0 as well, smaller, -1, bigger, 1. So doing the exact same thing for both sides. and it's bigger than 0. So now we know that it actually goes like this. So this will be the local max that we just got, and then local min. So now we have figured out what the critical points are. And now we can write down that the function y increases in negative infinity to -2 and 0 and positive infinity, the points. And this helps us understand what the graph looks like, and it helps us better in equations later. And it also decreases in -2 and 0. Alright, so knowing from before, this is mainly for increase and decrease. I may have overdone on critical points and talking about that we need critical points. This part does not need critical points. This part only needs these 3 points, not these 2. But now we're going to go through critical points and classifying the min and max. So now we actually do need these 2 and the main important part. But I was just trying to explain it earlier so we understand what the graphs looks like. So it helps us get a better image, because it actually does everything in this table for us to get understanding of the whole graph. So everything's the same. Step 1, derive, let y equal 0, then get the x. Same thing, same exact table from the left side, right side. You can see all I've done from the bottom is the question is completely different now. So we got to answer completely different, where when you get x equals -2, you're going to sub this into this equation and not the y prime anymore. The y prime is to realize about what this is, but now we want to know what y is. Now we want to know what the points of A and B is. So now that we sub x equals -2 into this equation, now we know that it becomes a -2 and 2, so that's the point of the local max, and for the local min it's going to be 0 and -2. I mean, you can clearly see when x equals 0, this is gone, -2, so that's complete proof. And we gotta say it like this as well. You must identify that it must be a local max and local min. So that's why I was clarifying about the critical points, because you must understand what the graph looks like and how it is. Alright, so we have got another equation, a different one, it's a completely new one, with a fraction power. So we're just going to y prime it very quickly, get through this quick. So as we all know, the a goes down for the x. This x plus 5, if you did not know, if you have an a here, it's still the exact same thing. It goes down, and then a minus 1. So that's a quick brief. But we turn it into a fraction, because when x -1, it becomes 1 over x very quickly. Alright, so you get the idea. We don't have to go through that much. So we're going to let it equal 0. And then 1 over the equation equals 0. But however, when you times both parts by this to cancel each other off, it's actually invalid. It will give you a 1. You can see this 1 right here. So when you get invalid, we're going to just say y prime is undefined at x equals -5. How do we get this -5 is by taking the denominator only. X plus 5, 2 over 3 equals 0. Sorry for my handwriting, I'm on a mouse. And so you just, and then x plus 5 equals 0. Yep, basic maths, I don't have to teach this stuff. And when we get x equals -5, then that's how we get it. We let the denominator equal 0 to find the undefined. Very quickly. Do not want to really get through all this, otherwise it'll be like a 20 million minute video. And when we get -5, same exact thing, smaller, bigger, and but you can see right here is that when we get smaller, right, it will actually increase. Interesting, goes up. Let's just draw a graph to understand more. Draw a graph, goes up, right? Undefined. But when you put it into a -4 from the undefined, it also goes up. So how do we know this? Is when we sub in and it's bigger than 0, it's obviously going up, and then when -4 and it goes bigger than 0, we usually expect that it goes like this, but because it's undefined, it gives a better sense that usually when there's an undefined, there's a very high chance, or most likely 100% chance, that it'll be a saddle. When you put a line here, this is why it's called undefined, because there's no min or max point. In a saddle, there's literally no min or max point. If you're able to find it, you're getting an Oscar. But it's basically just a saddle. So a saddle is look like this. One line goes through, and that's it. You can't really you're gonna get like a lot of weird stuff here. So we're gonna write here x equals -5, y equals 0. -5, the point of this is gonna be a saddle point, and we're gonna write here. We're gonna have to write here. It's no max or min. You must define it, otherwise you might lose marks. So now coming up to for finding min and max for inflection point using the second derivative. Now this is the this is the second one. All right. So we're gonna go through the thing where it's y. Oh, whoops. Y prime, y prime prime, double prime. So we can see that xa. This is what it looks like for xa, y prime, ax, a minus 1, right? But now for y prime, we're gonna let a minus 1 equals b. Is so you won't understand. If I write like this, you're gonna think that we took from the first one, but this is actually the second one. So ab actually ab x b minus 1. So if you're confused by this, I'm very sorry. I'm not really good at explaining much, but this basically means that when we have an x cube's easier, and you get a 3x square, and then we're gonna get a 6x. You know, because 2 times 3. You know, this is the b. Number 2 is the b. Now this is into the equation already. We already have it right here. So you can see that 3x squared gives us 6x over here. So this is the same thing from the top over up there. We have gotten the exact same equation, but now we're just getting y double prime. Now using the y double prime, when we let y double prime equal 0, it actually is much easier to find the x. But also more detailed. We can get into more detail of knowing concave up and down and other stuff. But we're mainly focusing on finding the max and min. So when we actually use the first derivative, we go up here, it shows us up, down, up. But when we use the second derivative, as I'm saying, we can find more detailed stuff. It actually means going concave up. Oh, sorry, no, that's concave down. Concave up and concave down. You can see it, imagine it by the arrow. Let's see, it's going down, concave up. Now, concave up actually gives us a min. Now, it's kind of weird having up, you know, going higher means it's a min. But going down actually gives us a max. So remember that. So after finding the y, after letting x equal 0 with these two values, we have a possible inflection point. Now that possible inflection point, we still have to verify it. So how do we verify it? Is we have the critical points, don't we? So we actually use the critical points of x equals 0, x equals -2, and we sub it into these two. And when you sub into these two, you get 6 bigger than 0, and then -6 is less than 0. So when you sub into the values, when it's bigger than 0, you get a concave up, which gives us a local min. But when it's down, when it's smaller, it gives us a down, and it gives us a local max. Now it's a bit confusing at start, but basically a bigger than 0 gives up, but also means min. Yeah, that's the whole story of it. And this also gives us a point which we could use. And when we make a table, now we're going to go to the table. So this is step 3. You always do step 3 before the table. It's much easier. We're going to go to the table for inflection point. And we're going to, we know that now is when -1, right? We sub 0, which is bigger. It actually gets bigger than 0. I didn't write the whole thing, but imagine bigger, smaller, right? Same thing. So, but negative 6 is smaller than 1, and it gives us a concave down. So, now that we know that concave up and down, the inflection point will give us, it might be not understanding at first, even me, but this is what it means. So we have a concave down first, right? That's the first thing because the equation tells us. And then we're going to have an up. And this is basically our inflection point. Now it's not has to be on the x-axis. It also can be anywhere. So if I draw this, and I draw this, and I drew it up here, this is the inflection point that we have gotten. Alright? Data not accurate, by the way. I drew it in a positive, not the negative. But you get the point. So the negative 1 is apparently this. Let's just say it's 1 right here, or negative 1. Yeah, negative 1 right here. And then the negative infinity to 1 is all the way up here. You know, all the way, this thing. So this gives us more detailed of the graph. Alright, so for finding all asymptotes, for the first one we're going to be going through is the vertical asymptote, and we got an equation up here. So we're just going to quickly do this. This is not hard, it's very easy. So for a vertical asymptote, we're just going to take the denominator. This only works for a fraction equation. So we're going to take the denominator only, and we can see that we let it equal 0. So x plus 5 equals 0, which will give us x negative 5, which is the vertical asymptote. And when you get the vertical asymptote, we're just going to let negative 5 to the smaller part, and then negative 5 to the bigger part, which is like what I said from the table up here. You know, we take the small, take the big. But for this one, now we're just going to do it even smaller. So before I did say do not use decimals, but for this one, we want it to be as accurate as possible. So we have to use the smallest decimal. So if you want, you can also go 5.0001, but no, we're just going to do 5.1 as it is the easiest, and negative 4.9. Sorry, negative 5.1. So when you sub negative 5.1, so negative 5, negative 5.1, and then negative 4.9, so smaller, bigger. So it's like the table thing, but it's just very quick because it does not need a table. We're going to sub into these two x's, and when you sub into these two x's, you will quickly get that is bigger than 0 for 5.1. And for bigger than 0, the closer it gets to the vertical asymptote, it's actually going to be y equals positive infinity, meaning that it's going to constantly go up closer and closer, but in a positive infinity. But when it's negative 4.9, it's smaller than 0, meaning that it's actually going to be going to the negative infinity for the negative 5. So that's just a simple way of knowing the vertical asymptote. Alright, so moving on to the horizontal asymptote. We got 3 case scenarios for horizontal asymptote to check if it exists or not. So the first one is if we're going to write n here and m here. So you will know that n is numerator and m is denominator. Alright? So the highest power of the numerator and denominator will be the one that you're going to be checking. So we can see that the highest numerator, the numerator and denominator power are both 1. So we're going to check here that if numerator is smaller, the power of numerator is smaller than the m, which is the highest numerator is smaller than the highest of m, then y will equal to 0. But if the numerator is equal to m, which is what we have here, as you can see they're both 1, power of 1, then y equals to the ratio of the numbers of the power here. So meaning that if this is 2 and this is 3, then it's going to be 2 over 3. That's the horizontal. If they're both 1, which in this case is 1, then we can see that lim y equals to 1, because 1 over 1 equals 1. Alright? But make sure that you remember that when n is bigger than m, then there's actually no horizontal asymptote. It does not exist. When n is bigger than m, we're going to have to go to the oblique asymptote, which I'll teach later. So, understanding how to find a horizontal asymptote, when we got the two scenarios that we should have, but we got n equals m. So moving on with n equals m, our one with the equation we got is 1. So y equals 1 is a horizontal asymptote. Now, to know if it's above or below, we're going to sub in a very, very high number. I recommend around 1,000, 100, 10,000, just, thousands. But this is the easiest number that I would like to check around with. It's the highest and average. Is when you sub the x, which is these two, negative 1,000. This will give you the number that's higher than your ratio. You're gonna be comparing it to ratio, not like this one where you compare it to 0. It's ratio. So when you compare it to ratio and it's bigger, then it will be above the horizontal asymptote, meaning that it's gonna be like boom. But if it's below, then like this, where you sub in 1,000 and it's actually getting smaller than 1, then it's below. So it's gonna be like boom. Alright, it's not accurate. I'm just showing that it's either above or below. It could be like this, either way. But just imagine this as a horizontal and it's above or below. That's all we need to know. Alright, moving on to the last part of the chapter 4. So we're gonna take the numerator and put it into this. So we're gonna like draw this out just for you to understand more. This is the numerator m, and this is the denominator d. I'm gonna call denominator d so it's easier to understand. So you can see that x minus 4, this denominator is placed on this side, which is here, and the numerator is placed on this side, which is n. So you get the idea to understand how to write it. So how do we do this? It's called long division. Is where we get a remainder or no remainder, and then we get this top part here. So to do this is I will show you from this part. We're gonna look from the left side. Alright, so we take the first one over here, which is 3x squared, and then we're gonna take the x here, which is the highest powered x. So 3x squared over x, which will give us 3x is what equals to 3x, which is right here. So to get the bottom part here, we're gonna sub 3x into this. So now after you've gotten 3x, we are going to x times 3x into x minus 4, and this will give us this right here, 3x squared minus 12x. So after you've gotten all this, now we're gonna minus it, right? We're gonna minus it, the top minus the bottom, and we're gonna put a bracket on these two. You can very see closely, and a little minus there is because when you open the bracket, 12x negative will become a plus, which is how we get the 4x. So 3x squared minus 3x squared is a 0. That's very good. That's what we're looking for. We need to make it a 0 to keep going forward. Otherwise, we're not able to. If you don't get a 0, you're doing something wrong. So you must get a 0 in order to get to the other side. So make sure you're not just blindly doing this. All right. So now that we have 12x, opening the bracket, negative 12x with negative, both times negative, positive, making it 4x. So 12x plus negative 8x. We take the negative from here as well, will become 4x, right? Remember that. So now negative 7, just going to drag it down here. You can see, I'll just draw an arrow, hold on. Boom, yeah, that's a terrible arrow, holy crap. Alright, so after drawing the arrow, I mean, you don't have to. You're just going to continue on. So how do we get this 4x here is this exact same thing. You're just going to take the 4x that we have gotten after minusing these two is 4x over x, which will equal to 4, right? That's 4. Oh my god, I just moved the whole thing. Now, after getting the 4, you're going to just put it right over here. Yeah, we're going to do that. After doing that, then you get negative 16. by timesing in, as I said. It's a repeat. You're going to repeat this until you have gotten no x's and just the remainder 9. So luckily for this one, it's very short, but there are some that takes a very long time. So for this one, it's just 2 steps, 1, 2, doing the exact same thing, minus, minus, plus, because negative, it's pretty high, but it's right here, negative, negative, plus, gives us positive 9. Alright, so next step, it's quite complicated. This requires memorizing. Not that complicated, but you have to memorize it in order to get marks for the exams. So we're going to put y equals 3x plus 4, which is this, and then the same exact thing is plus, alright, it has to be a plus, 9 over x minus 4. Now if you do get a negative, then yeah, you will put a negative there, but because it's a positive, then yeah, it's a positive. Then we're going to go below, okay, now we're going to add a lim. So you must add this. This is very important. Lim x approaching positive and negative infinity for all of it. I didn't put it here. It's yeah, there you go. Yeah. So after you've done that, just putting in some normal stuff. There's no calculation here. It's just instantly 0 for this. Well, this whole thing will just become 0 instantly. There's no calculation. There's no other thing. It's just instant. And then you're going to be left off with lim 3x plus 4, which is just 3x plus 4. You don't have to write this because your final answer is actually like this over here. You're going to be writing down sof y equals 3x plus 4 is OA, which is the oblique asymptote. And that is it for my part of chapter 4. This is the whole thing. We're pretty much done with it. My partner will teach you the rest.